Hi everybody, my name is Steve Klein and I work for Altera, and I'm basically the digital CAD manager for Altera worldwide. And you may know us from our FPGAs, but FPGAs are growing and consuming more and more ASIC content. So we have quite a bit of traditional kind of P&R development, and that continues to grow, and including the new the processing cores that we add to the FPGAs as well. So I'm going to talk to you a little bit about Lynx and what we've started out at Altera, and this really came about from a need and a criticality to look for a better solution and replace what we currently had in-house. The previous generation was called RTL to GDS, which everybody here is probably familiar with, an in-house solution to basically automate your synthesis through analysis and closure flow. But you've probably seen that this is kind of a costly endeavor. It takes a lot of manpower to support it, takes a lot of manpower to release new versions, develop it, and also support it, and support it to your design engineers. And we wanted to look at leveraging a global support team and have a better infrastructure, because we do have sites in Austin, San Jose, and in Penang, Malaysia. Also, we noticed that no matter how much effort we were putting into this flow and development, we were pretty much behind all the time, that there were always new capabilities, new facets of flow development, whether it be LSF job scheduling or job submission protocols, that we just couldn't keep up with other solutions on the market. So we decided to look at Synopsys Lynx, and we put some pretty simple objectives in place to get started, and that was it had to support integration of our Foundry flows, our alignment with our Foundry team, and we'll talk a little bit more about that as we go through the presentation. The next was to debunk the myth that Synopsys Lynx only supports Synopsys tools. So we set out to look at our flow, what third-party tools, and I'll go into some detail on that as well, about how easy it is to implement third-party tools into a Lynx-based flow. We also wanted to evaluate the dashboard and data collection capabilities, and then of course it had to work inside our own internal environment, which includes our internal resource management, LSF, and IC Manage for data control. So this is what we're going to talk about in terms of our evaluation. The first thing that we'll spend some time on is the Intel 14 nanometer utilities. So you've probably seen or heard in a press release that we are one of the first partners with Intel in their Foundry business, and we are generating our latest FPGA, or we're developing our latest FPGA on 14 nanometers. So we had to make sure that whatever environment and flow control solution we were adopting we could easily integrate the Intel utilities for their Foundry, their specific requirements to build in their process. This integration was very straightforward. I can't go into the details because that's all protected by the NDA, but in the implementation space, there was quite a bit of, there were quite a few utilities, and basically in their toolkit, that had to be adopted. We found this very easy to do and completed that task. Since it was straightforward, their utilities are basically based on a common set of variables, a common set of procedures, and because that was defined, we could basically register them in the Lynx system. So I'm kind of going to focus on what we did in Lynx versus what the utilities actually are. But because we could leverage those utilities and basically track them, we could then use them for all facets of design. So if you needed to have, say, a don't use list, you could create one variable for a don't use list and pass it to any stage of your flow that needed to have access to a don't use list. It put a control in place that meant we could keep track of what we were using and how, and other parts of the flow could reference them. We would also develop new custom variables. So the variables that Lynx depends on, we could use, but we can also generate our own variables to drive the flow. And then, of course, now we have to maintain them and leverage them to different parts of the flow. And over time, it was easy to integrate these best practices and utilities. So we learned from testing, we learned from the utilities from Intel. We partnered with their Foundry team to understand why they were building the flow the way they did. And integrate that into the Lynx environment. And in the end, we ended up generating, based on the Lynx-based RM flows, we ended up incorporating all the Intel technology in a very Intel-centric methodology so that we can absorb their utilities. We can, every time they drop something new from their foundry to us, we can absorb it in just a matter of a day or two into our development environment. And of course, my development engineer is sitting here in the audience saying it takes a lot longer than a day or two, Steve. So that was a joke. So Josh, don't laugh too hard at that. Okay, so again, I can't go into details of what the utilities are actually doing, but I will say that with a new foundry, there's quite a bit of change going on and quite a few drops of this technology, and of course they're making changes just like everybody's used to in this loop when you're on the edge. So this has been something we found very easy to adopt. Then for third-party integration, we had to demonstrate that conformal LEC would work inside the flow. Now obviously that's a cadence tool, and the Synopsys guys are probably not so happy that I mentioned their name, but that's okay because they wanted me to talk here today, and I said I'm going to do it. So the thing I want to dispel is that conformal LEC is fully embedded and automated inside our Lynx environment. So we run synthesis, and then after synthesis we do an automated RTL to synthesize gate level netlist comparison. It runs to completion. It reports all errors. The error parsing utility, or basically the log file parser that's inside of Lynx, automatically parses a cadence log file and comes up with error conditions and reports metrics. So there's no reason to think that Lynx can't support basically any tool. I mean, we have a couple of Lynx-based flows at Altera that don't use any Synopsys tools at all. They only use basically our homegrown utilities and tools and scripts. So you can build anything into Lynx, and so just putting a third-party EDA vendor tool in there is not a problem. It's also, I'd like to point out that it's very easy to populate custom metrics. So we can embed, even in the conformal run, we can embed certain metrics that we want to collect on the Synopsys SQL server for metric collection. We can embed those metrics as well, and it's as simple as basically one-line script changes to the flow. And finally, I'd like to point out that this only took us a couple of days with a relatively junior set of engineers with their experience with Lynx and the flow control here. We embedded the tool, embedded the scripts, and had it functional within about 2 days of development time. So that's kind of the power and the ease of use of the flow. And finally, one thing that I'll point out here is on the actual flow charts that we see on the right. You can customize these flows very easily right from the GUI environment. You don't have to pre-register a flow to make it functional. You can change the connections, you can change the pointers, and they even have what we see here in the green box in the middle is a MUX control. So you can actually choose multiple paths or one path and look at the output when it's done. So there's quite a bit of flow control built in right from the GUI as well. So let me go into a practical example for just a minute. So we have a CPU core that we are wanting to implement on 14 nanometer technology. So we started with an investigation of the optimization techniques as enabled by Lynx. So one thing that we do, and it was slightly controversial when I made this decision, is I bring all the flow control local to the user. So this is that heavy-handed CAD sets up a flow, but I can't edit my flow, so I'm not going to use the CAD flow, right? Or CAD provides a flow and brings all the flow control local, and I can edit the flow, but now it's not, is it actually their flow or is it my flow? So in the Altera environment, I let users hang themselves. I bring all the flow control local, I let them change the flow, I let them edit it so that they will stay using the infrastructure, and we leverage the commonality. It may be kind of contentious. It was when I made the decision, but what I've seen is it means that people use my flow, right? They use my flow control environment. They know that they'll have the ability to go edit what they need to edit and change what they need to change. Here we have a case where, for the evaluation of the CPU core, a user wanted to change the flow in any number of ways, basically have a consistent way to run the flow, collect the data, and compare the data. And in this case, they changed the flow scripts, they changed the run scripts, they changed variables, they changed effort levels, they changed options based on talking to their Synopsys AE, etc. And because they're local, they're able to make the changes, spawn the runs, populate the data, and then use the QOR viewer, which is provided by Synopsys as well, to compare the results across many runs. This was all done with a minimum of setup and by a user who'd never really run Lynx and didn't have that much experience running ICC beforehand. And in conclusion, what we found was that we absolutely had to have a very important switch, and that was consider routing true in this technology. And that basically allows us to consider global route at the time of placement inside of ICC. So from all that experimentation, which was, I don't know, 40, 50 runs at least, we were able to debug what problems we were seeing with the core and come up with a conclusion that we needed to make a change to the default scripts. And it turned out to be, there were several things we wanted to change, but the biggest thing we hit was the consider routing true option. So because he found a needed option for the flow, we can add that to the default flow from that point forward. So then we take it, put it in the default flow. Now everybody who starts out a session using the our CAD flow will now get that new change. And so it's a very easy path of looking at what the user did, leveraging a user experience, editing the CAD flow, and passing it on to the new users. It's also easy to find what they changed. Because I know what he built his flow on, I can basically do a diff. A very simple diff of his flow scripts versus what I released to him. I can see what he changed. And for all the managers in the audience, that should sound really nice because it means you can actually see what's changing from one user's run to another, or what's changing from one user's run to from the baseline, so that you can have faith that they're using the flow you expected your designer to use for sign off. And this can catch things like changing don't use list variables, changing VT. Your VT percentages or your mixed LVT percentages, et cetera. So you can catch things very easily. And because we have this, we can pass it on to new users, or optionally, we can even show somebody how to manually add that into their local flow script so that they can get that option as well. So it's very easy to pass on and easy to flow out, to pass out new flow changes to the user base. A few thoughts, right? So the Lynx system is very well thought out. It's very robust in terms of we've been using Lynx, rolling it out in production since June, and before June we were in a development mode for about 5 or 6 months. So we've never had a failure or a crash of the Lynx system except when we had our own IT problem and the metric server went down. So I can't really blame Synopsys for that. And when people ask me what's the single biggest reason to use Lynx, is it because their flow, the underlying flow that runs ICC is so amazing I have to have it? Well, no, that's not the part of Lynx that you want to embrace. The part of Lynx that you want to think about is flow consistency and portability, right? That we can move people into into a Lynx flow and then bring another user who's used to the same environment in, and they're immediately effective. And we'll talk a little bit more about that in a minute. So I would say that the script and override control, metric collection, and job scheduling and profiling, which I'm not going into a lot of detail there, but we actually built a very comprehensive physical verification part of the Lynx flow, which with our new Foundry vendor, we run multiple DRC decks, actually quite a few. So figuring out how to run your DRC jobs effectively is something now that we control completely from Lynx. So it figures out how to spawn them, how to schedule them, what are the long poles in the tent. It does job profiling, manages all the system resources, and that's all. So the user, it's transparent to the user. They don't have to worry about it, and that's all built on top of Lynx. So recommended areas of improvement. I've kind of been harping on this for a while. Snap and NWrap from Magma. As Calvin said, I used to work for Magma, so I'm a little bit of a bigot about Snap and NWrap. But we really could benefit in the flow in the Lynx environment with Snap and NWrap. It'll just make overrides easier to manage. And then just a word of caution, right? Some people look at Lynx as kind of that registered file or timestamp-based flow control manager. Competing tools like FlowTracer do this really well. That's not the complete value of Lynx. Lynx does so much more than that. If you're looking at just a file-dependent flow engine, then this may not be your answer. We need to look at some of the other pieces of Lynx. And then the GUI customization is not as easy as you might think. So these are just a few places where I think we can improve Lynx, and I've given that feedback to Synopsys. So next app, so Lynx will be and is the flow control solution of choice for Altera. We are adopting it in all design teams, and I talked about the example of the core that we ran through. We also have quite a few other groups inside Altera that are interested, including the ICV or PV scheduling area. That has also shown to be a very successful collaborative effort with Synopsys, where we went to them with the problem, we showed them the magnitude of scheduling these jobs in this space. They worked with us, helped us build a custom solution, and we've now leveraged it. And also, just a side note, what's really cool is the other day I said, you know what, I want to see if I can go into our metrics browser and see who's actually using it, get a list of all the IP, all the users, and from our metric collection engine, I wasn't sure I was going to get the data I wanted, and it only took a little bit of time to run the report and basically get that, oh, I could go see exactly what part of this verification engine was actually in use and who was using it. So there's a whole bunch of power that you get with Lynx to see what's actually going on when, kind of for some reason your design teams don't want to answer your direct queries about, hey guys, who's running DRCs right now? Okay, and then a couple of comments that I'd like to leave you with is, the first quote comes from a 20-year developer who said, I am so much more productive in ICC with having Lynx wrap this. Now, Synopsys is probably happy to hear this. He ended up running significantly more experiments and tests of his data because he had Lynx. The ease of having a flow control solution and being able to spawn jobs and analyze the output allowed him to run many more jobs than he would have if we didn't have Lynx, or at least it would have been a lot harder for him to run all those jobs. Ramp up on Lynx, and this is a junior designer. This is from our Penang side actually. When I asked her and her team, they're one of the first adopters who kind of went off on their own and started using our flow. I said, I really would like to know what it takes, and she says, well, I think in 1 week you're effective. In 2 weeks, I fully understand exactly what's going on in this flow. And that's kind of powerful, right? I mean, I need to hear that feedback that I'm not making something that's so complex that nobody really understands how to use it. And then the last quote is, we actually brought in the Synopsys services group, and what was kind of impressive here, and you might look at that quote and go, well, I would expect the Synopsys guys to like Synopsys flows, right? But I think the value here is that consulting group is valuable to me, and knowing that they can come in and look at my flow and understand what we're doing and be immediately effective means that I know where I've got a set of resources that I can go to when I need to get something done from that services group. So that's the value to me of having them come in and within a couple days be running designs in our flow, on our site, on our computer, exactly the way we run our flows. And as a side note, I also got a list of here's 3 or 4 things we'd like you to fix in your flow to help me make the flow better from their perspective. So in summary, I would say that Lynx has done everything we expected it to do, and it's very powerful. So I would consider, especially if you're contemplating kind of building and maintaining your own flow control engine or resources to do that, I would consider Lynx. So thank you.